All right, let's jump right in. And we're not talking about some far-off science fiction concept today. Nope. We are looking at a real-world case where an AI agent is already in the lab, doing the work, and completely changing the game for scientific discovery.
So I want you to really think about this question for a second. What if that slow, painstaking process of scientific discovery, all that trial and error, what if you could compress it from months down to just a few days? I mean, what would that do for new medicines? And what if that power wasn't just for a few elite labs, but for pretty much any lab? That's the truly revolutionary idea we're digging into.
To get why this is such a big deal, we first have to step into the super high-stakes world of developing new medicines and products. It's a world that for decades has been stuck behind a massive, expensive, and incredibly slow bottleneck.
I mean, think about it. Bringing a new drug to market can take over a decade and cost billions of dollars. And a huge chunk of that time and money gets sunk into one critical step, making absolutely sure the product is pure, safe, and effective. And the lab process for doing that is where everything just grinds to a halt.
So let's take a look at that process, the old way of doing things. It's really a story of manual labor, a scientist's best guess, and a whole lot of doing the same thing over and over and over again.
The process at the heart of this whole problem is called liquid chromatography. I know, it sounds super technical, but think of it like this. You've got a complex soup with all these different chemical ingredients mixed together. Your job is to find the one perfect recipe, the exact temperature, the right solvents, the perfect timing to separate every single ingredient out cleanly. For decades, finding that recipe has felt more like an art than a science.
And as you can see, the actual workflow is, well, you could call it the manual grind. A highly trained, very expensive scientist makes an educated guess. They run an experiment, which takes time. They check the results. And usually it's not quite right. So they tweak one little thing and do it all over again. And again, this cycle can literally go on for weeks, sometimes even months, for just one single product.
And the consequences of this are huge. You're tying up your best scientists doing these repetitive tasks. You are burning through tons of time and really expensive lab materials on all these failed attempts. But the biggest cost? Every single day spent doing this is another day that new, potentially life-saving medicines are delayed from getting to the people who desperately need them.
But what if you could change that entire system? What if you could just take the guesswork, the repetition, and that enormous time sink right out of the equation? Well, this is where the hero of our story comes in, the AI scientist. So here on the left, we've got the before picture, a slow, super costly process that needs those elite experts we were just talking about. We're going to leave that after column blank for just a minute, but trust me, the reveal is worth the wait.
Now, what's really cool about this is how it demystifies the whole thing. This isn't some magic black box. It's actually a system of 3 distinct parts that work together. You've got the hardware, the actual machine that runs the experiments. You've got the AI brain, that's the software making all the smart decisions. And then you have the control platform, which is basically the translator between the brain and the hardware. See? Pretty simple when you break it down.
So we know the parts, but how does this AI agent actually think? Let's pop the hood and see exactly how it gets the job done step by step.
This right here is the classic loop for an AI agent. It all starts with a human who gives it a high-level goal, something like, hey, separate these 5 compounds for me. The AI perceives that goal. Then it reasons. It uses its algorithms to predict the best way to start. Next, it acts. It tells the hardware to run the experiment all on its own. And here's the absolute key. It learns from the result. It analyzes the data and instantly self-optimizes for the very next run. It gets smarter with every single experiment it does.
But this probably raises a big question. Who's really in charge here? Is the AI just running wild? And the answer is super clear. The human scientist is still the boss. The human sets the overall goal and defines what a good result looks like. If anything goes wrong, the system immediately alerts a human. And most importantly, no method gets used without a final review and an official sign-off from a human expert.
And this quote from the source material just sums it up perfectly. The AI hasn't replaced the scientist, it has promoted them. Instead of being down in the weeds, manually running experiment after experiment, the scientist is now the high-level manager, the strategist who makes the final call.
Okay, so we've seen the problem and we've met the solution. Now it's time for the payoff. What actually happens when you put this AI scientist to work? Well, the results are, to put it mildly, transformative.
So remember that before state we looked at? Let's fill in the after. A process that took weeks or even months now takes days. A task that required an elite, hard-to-find expert is now accessible to way more labs, and a costly, wasteful process becomes efficient and fast. This isn't just a small improvement, it is a total paradigm shift.
And this chart really just says it all, doesn't it? Look at that difference. We're not talking about a 10% or 20% improvement here. This is a quantum leap in speed and efficiency. We are literally compressing months of work into just a handful of days.
Now, this is incredibly impressive for one single lab process, but the implications here are so much bigger. This isn't just about chromatography. This is about the future of scientific discovery itself.
And that right there is the key takeaway. When you can automate this level of expertise, you're not just making things faster, you're democratizing it. You're taking this complex art form that used to belong to a handful of elite experts and turning it into an accessible, standardized tool that almost any lab can use.
So, why does this all matter? Well, it speeds up the entire R&D pipeline, which gets life-saving drugs to market faster. It empowers more labs and more scientists to do high-level work they couldn't before. And maybe most importantly, it creates a blueprint, a proven model for how autonomous AI agents could be used in all kinds of other complex scientific fields, from material science to genomics.
Which leaves us with one final and pretty fascinating question to think about. We've just seen an AI agent master one of the most complex, hands-on arts in modern chemistry. If it can do that, what other scientific bottlenecks are about to be broken? What's next?